Hey guys, just make sure the audio stuff is working for this. No echoing off. And yay, there we go. So, everybody hear me? Probably you guys don't need that, but I think some of the people on the stream do need the microphone at least. And for some reason, it does seem to be going a little higher than it should be. So I'm going to do that. There we go. And awesome. Can you check that? Make sure it's working right. So, welcome everybody. Again, so this is going to be the second month in a row that we're doing here at Mars Commons. Based on the turnout here for you guys, this is seeming to be one of the best things we've done for the group, is probably introducing that $5 little charge. Does everybody here enjoy the pizza? Was it good? Yeah? Do you guys think it was worth it, having that extra little bit, making sure that you guys are showing up for that for the group, but for you guys to be fed and whatnot for that? So I think that was a good thing. Just a quick reminder for anybody that's on the stream or for anybody that is here, if you are tweeting tonight, I strongly encourage it. We're in Mars Commons, not Mars DD, even though technically they're the same thing. But Mars Commons is where we're being hosted tonight, thanks to the kind people there. Our hashtag, which I'm going to be trying to push for all the events and for the group, is actually going to be HTML5TO. It's a bit shorter than the @HTML5_Toronto, which is the actual account that we have. So if you are tweeting, if you want to include that instead of doing the long one so you can put this massive tweet together, you're more than welcome to. For the code tonight, I think we're also going to have some of the links in the description. There's a couple little code cleanups that I hear are going to happen, just a couple corrections to the code online because you guys are modifying stuff tonight. But we will have all of the links together as well in the description of the event tonight. So if you want to download that tonight, you're more than welcome to. But a couple big thanks go out. First of all, Web Not War. Some of the people at Microsoft obviously coming in as sponsors for the group. I want to give a big shout out to them. We are doing an event in 2-3 weeks?
Yep.
So,
3 weeks.
Is it 3 weeks? Okay. So we've got an event in 3 weeks. That's going to be an HTML and JavaScript gaming event or workshop, code along. Although Microsoft is a big sponsor of it, there is a couple talks from Microsoft. What I'm trying to force and what I'm trying to encourage other people to ensure is that it's not just only Microsoft technologies. We're a web group. You guys are a web group. So it's going to be a lot of web technologies. I did speak with a couple people here, at least one person here today that's it's like, oh, it's going to be only things that are on web platforms for Microsoft. No, it's gaming using JavaScript, using HTML. It's code-alongs. It's community-driven content. So I will have a link to that both on our site. It's on your site. DevTO is also a partner for this, so they're going to be involved with it as well. There's links in all over the place. Look on social media platforms. Join us out for that as well. So that's Web Not War, and kind of a plug for our thing as well. But a second partner who is our, I believe, H2 level sponsor, and for anybody who gets the reference, H2 for the, anyway. Semantics! Oanda, which I will actually invite them up to give a little bit of a description of who they are. I think last time I had gone through this as well. Went out to the office to make sure that they are the type of sponsor that we want. It was very interesting, and I really thought that they are a great sponsor to bring in, especially because their API that they're releasing is very designed for developers and to really help build the types of tools. So without further ado, I'd like to invite you up to obviously have a little bit of a talk about who you are.
Thanks, Matt. And also thanks for not mentioning the fact that when you visited the office, you kicked my ass at ping pong. So my name is Jason Primo. I am the Director of Development at Oanda Corporation. Most of you, I'm going to venture a guess, don't actually know who or what Oanda is. And that's not really all that surprising because for about the last 15 years, we've been totally internally focused. We've been just sort of having our heads down, writing software, and not really participating very much in the community. And that's something that I'd like to change and we would like to change as a company. So sponsoring events like this are something that we find think is going to be really important to getting our name out in the community. And it's also events like this that I think are actually really awesome to sponsor because it's a way for us for this community in particular, because it's HTML5, obviously. That's sort of the next future generation of technologies that are coming out. And we're actually designing a trading platform based on HTML5. So what Oanda is we're a foreign exchange market maker. And what does that mean? That means we are kind of like a stock trading company, an online stock trading company, but we trade currencies instead of stocks or bonds or anything like that. So if you think you want to potentially make some money based on the movement of the yen or the euro or whatever currency, you'd open an account with us and you would buy or sell currencies. Something that's probably a little bit more interesting is that we're actually more of a technology shop. We're not a stuffy finance company, as Matt can attest to. I'm especially excited to be sponsoring this event and participating here today. You guys are doing the quadcopter thing, which I think is really awesome. A little shout out to Aviana here, who during one of our last hackathons did a trading interface that you actually have like a brainwave sensor kind of thing, and you could actually buy and sell currencies with your brain. It was pretty cool. So that's the kind of innovation and technology thing that we're interested in. We're not just about pushing bytes around. We actually really care about cool and fun technologies. We're not a finance shop. We don't wear suits or anything like that. So actually, if you want to see that mind trading demo thing, I'm going to give a little shout out for another event, if you don't mind. We're going to be at Hacker Nest on Monday. So if you want to go check that out, we'll actually be doing a demo of that mind trading platform. So you strap the little doohickey on your head, and it'll you can try and test your mettle at trading. So that's basically all I wanted to say. Oh, I'm sorry. And one last thing is we are, of course, hiring. So if you think you're hot stuff, please talk to me or some of the other people here from Oanda, and we'd love to talk to you and see where you might be able to fit within the organization. Because it's people like this that we're actually really the most interested in meeting. Because you're not just doing software as a job; you're here on your own time, learning about things that you probably aren't going to ever do in a job-like environment. But you just think it's fun and cool, and that's the kind of person that we want to invite into our environment. So thank you very much, Matt.
Thank you. So yes, if you know how to control things with your mind, you know where to go for a job. That's seriously really cool. And yes, Hacker Nest is a very, very friendly group with us as well. We ran events with them in the past, so big shout out to them as well. Without further ado, I'm sure I'd like to get started here. Our great presenters, Taz and Joshua, are presenting, as you guys are well informed now, hacking along or coding along with a browser in JavaScript for quadcopters. So I'm not going to do a massive interview. Just know that great stuff. Are you one of the organizers of the JavaScript Toronto as well? No, just Taz. So Taz is the organizer, the only organizer. Yep. The only organizer of JavaScript Toronto. They don't do a lot of events over the summertime, over the year. How many events?
We actually do an event every month, but it's every other month is a tech talk night, and then the remaining months are pub nights. So I invite you to all come out to those. The next one will be April 11th. That will be a pub night at Elephant and Castle.
Cool. So torontojs.com. Visit that. Without further ado, I'm going to switch on the other microphone here, and hopefully for anybody that's online, I apologize if you get like all, I will fix it in a minute, but for everybody here, you guys should be able to present along or hear along. So cool, let's get started. Thank you.
Awesome. Perfect. So, we good to go? Awesome. Okay, so I'm just going to attach my brain adapter for the quadcopter. No, I'm kidding. I'm kidding. If only, right? If we could only hook up that brain adapter to the quadcopter, I'm sure things would be chaos.
I have a feeling that you'll end up doing this test.
That would be pretty amazing, actually, yeah. So anyway, as Matthew mentioned, I organize a Toronto JavaScript group, and last Thursday we actually gave a talk, the same talk on quadcopters and JavaScript, but we have a few more additions and surprises in here for you. So to give you a bit of history on the talk, I actually sit next to Josh at work on a few days of the week, and basically how this all got started was I turned to Josh and I said, well, Josh, how can we destroy the human race? If we can get screen slides up on there. How can we destroy the human race? There we go. What we ended up, we started thinking about a few ways to do this, and there was like the whole 2012 apocalypse thing.
The Mayan.
The Mayan apocalypse. We could have replicated that somehow. There were a few more ways.
Inappropriate comments and tweets at
making
tech conferences.
Making inappropriate comments and tweets at tech conferences would have not ended the world, but at least
certainly
it would have ended our employment
yeah.
at said company. But what we did settle on was Skynet. Skynet did a pretty good job at destroying the human race. I mean, robotic drones flying around, and that did a pretty good job. So what we're gonna show you today is our version of Skynet. We're labeling it V0.1 Alpha. This is alpha technology. It's not finished yet, so please beware. Without further ado, my colleague Josh will tell you how we got started.
So in the beginning, we were trying to come up with an idea initially for our JavaScript Tech Talk night. So we thought, hey, let's do something with hardware, because hardware and JavaScript are very close to meeting each other, especially now that you can run JavaScript on a server. But ultimately, it really comes down to the fact that hardware's cool, especially for software developers who are just coding in a terminal all day. Being able to play with hardware is a cool prospect. So initially we had two ideas. The first was to use JavaScript to write a device controller, a device driver for one of these, an Xbox controller. The other one was to basically do the same thing, but write a driver for a dot matrix printer. Those are middling ideas, but they didn't really fit the main criteria that we established. In that, dot matrix printers really kind of suck at killing people. They're not Skynet enough. So we thought a little bit more. And Taz, what were the other ideas we came up with? Anything better?
Yeah, you know what? We did come up with a better idea, and our better idea was to actually use a quadcopter. I mean, they're much better at killing humans. I mean, like, they fly. They're like robotic. They can be potentially completely autonomous. You don't have to have any human interaction at all. They have a video feed attached to them, so they can possibly do some facial detection and detect where the humans are in the room. And you can attach laser beams to them. So those are pretty damn good at killing people. So anyway, the first quadcopter we got was this thing, and as you can see, it's made out of solid steel. You can definitely put a cap or two into that, and we'll take it, no problem. It's pretty good at killing people.
This wasn't just an idea; we actually got it.
We actually got this.
This was
drone.
purchased.
Yes, this was purchased, and it's pretty awesome. So as I mentioned, it's made out of like steel. It's all the blades and everything are all also like aluminum, I believe. It's a pretty crazy device. It's powered by an Arduino, so you have to essentially code. Let's see if I have notes. You have to essentially code the microcontroller to actually talk to the actual rotors and actually do all the coding to make sure all the rotors are in sync. It has a camera attachment. If you can see this here, you can actually attach a camera to that, so that can operate independently of the actual drone itself. It's a serious piece of kit, and it's pretty awesome. So what's next with this? So first and foremost, that kit doesn't come with a battery. So you have to go out and buy your own battery. So once you have a battery, you have to assemble the thing. It all comes in pieces. You have to physically assemble it together, like solder on, all the different components and so on and so forth. After that, you have to code the Arduino microcontroller, as I mentioned. So you have to physically do all the math and like for all the rotor rotation, code it on the actual Arduino, and so on and so forth. Next, you have to actually speak to it. So this is fine as its own device, but how do you actually communicate with it? How do you actually control it? So you have to actually buy a communication interface, so like a Wi-Fi shield for Arduino. There's a few other communication devices. Get that, hook it up to the Arduino, communicate to that to talk to the Arduino, and so on and so forth. Once you have that built, you need to code the client. So are you doing this with some sort of joystick device, or are you doing this with a controller?
Yeah.
Some sort of you need some sort of client interface to then communicate with it. And then once all that's done, you can actually fly it. So Josh and I thought, that's a bit much, considering it's $700 for just the hardware alone, including shipping and customs, not including the battery, not including the Wi-Fi shield, not including whatever controller you use, and that's a bit much just to kill someone. So what's next, Josh?
So we went back to the drawing board and came up with this. It's the ARDrone 2. It's just a consumer device. You can get it at Best Buy, Future Shop. It's relatively inexpensive. I think we spent $290. I mean, as far as these kind of things go. It's got really easily replaceable parts, which we actually ended up needing to use. Day one, within an hour, we broke this crossbeam and had to develop while it basically couldn't fly. So a couple of the reasons that we went with it beyond those are that although it has a closed firmware, it has an open client SDK. And that's important here because what we're really interested in doing is figuring out a way of writing client-side code to control it, right? So just to be clear, the actual drivers and software for the microcontroller inside of this, that's all pre-written. That's out of box. We didn't have to do that. So fundamentally, it solved this challenge that we would have had with the AeroQuad of, oh man, how do we write all of this stuff and assemble it? And that's kind of the core feature, I suppose, that it gave us. But the other really big thing that it solved was the networking problem. So instead of having to design some kind of radio communication, we get it out of the box. This thing has a Wi-Fi broadcast chip on it. So it actually creates a Wi-Fi network. And you can connect to it. It's just a GN network. And it has an IP address. And its SDK operates on TCP UDP protocol.
And sorry, Josh. At this point, I was going to chime in and tell you a joke about UDP, but I'm afraid you probably wouldn't get it.
You might have to send it again. So there are 4 open ports on the device. 4 open TCP and UDP ports. They're for navigation, for video. There's actually a camera on this thing. And then command and control ports. So that part of our problem is sort of solved, right? We've got a device that comes out of a box that we can turn on, that we don't have to assemble or program the firmware for, and we've got a way of talking to it. But where does the client-side part come in? And I think Taz is going to outline some of the constraints that we wanted to put in place to deal with that problem.
Yeah, sure. Thanks, Josh. So a few of the constraints that we had for this. Well, first and foremost, we both love JavaScript, and unfortunately, Reveal.js isn't really revealing on our subpoints here. But anyway, we have a few throughout the presentation, and unfortunately, it just doesn't appear. But anyway, some of our constraints, we want to do this entirely in JavaScript. So Josh and I, we both love JavaScript, and I have a passion for doing kind of ridiculous things with JavaScript. So hardware access, just crazy things that you normally wouldn't do in JavaScript. So we want to do this only in JavaScript. Second of all, we want to do this only in the browser. So doing this all on a server, doing this all where you have immediate access to the actual native layer, that's easy. Doing this in a browser, you have to do it all through browser technology. That's fundamentally difficult, and I think a lot cooler to do it in a browser than just do that in the server. So Node.js, for example, totally out. We're not going to use Node. We're not going to use Rhino. We're not going to use Nashorn. We're not going to use any of those server-side JavaScript VMs. We're going to use the browser. So how do we actually do that? Right? It's probably what you're thinking. How do we communicate with TCP and UDP in a browser? It's a bit difficult. So what we found is we can actually do a Chrome packaged app. And what these are, they're basically native desktop apps that run in a browser. So it's, at least it's Google's version of that. So these Chrome packaged apps are supposed to be cross-platform. You can run them essentially wherever you can run Chrome. So it can work on Linux, Mac, Windows, etc. In some sense, it's essentially Node.js in a browser. Like the actual library that they provide to you is very similar to Node in that you have sockets, you have file system access, you have a lot of stuff that you can do with Node.js. You can also do in Chrome packaged app, which makes it pretty cool. It's a new platform. It's on top of Chrome extension, so it's not the Chrome extension API. It's actually built on top of that. So if you built an extension in the past, it's similar, but you can do a lot more stuff now. And it's getting a lot of buzz. As I mentioned, it's cross-platform, so it can run on Chrome OS and the Chromebook. So you can build basically desktop fielding HTML5 apps for those devices. And very soon they'll be in the Chrome Web Store. I believe it's just extensions right now in the Chrome Web Store.
Yeah, but soon they promise to open it up to packaged apps.
Cool. So soon the packaged apps will be on there as well. And I'll give it back to Josh to explain how we actually did the hardware access.
So one of the things that a Chrome packaged app gives you is native hardware access. So just to be clear, when you run a packaged app, it's literally a Chrome window with a DOM, just like every other Chrome tab, but it just doesn't have an address bar on the top. So it looks like, to the user, like it's a native app. And one of the things you get in Chrome packaged app land is native hardware access. And there's a couple of things you get. You get USB, and you can literally just read from raw from a USB device. You get file system access, as Taz mentioned, so you can read and write kind of arbitrary data to a sandboxed environment on the user's machine. You get access to Bluetooth, so you can read Bluetooth devices. And then lastly, which is really important for us, you get socket network access. So you get Chrome exposes really, really low-level networking to you. And that's ultimately what we took advantage of. So to create a Chrome app, you create a manifest file, and it looks really simple. So you specify the version. In this case, everyone's using version 2 now. You specify the version of your own app. You give it a name. And then you've got this app object. And basically, when you make a Chrome extension or a Chrome packaged app, when the user runs it on boot, Chrome will start up some background scripts for you. And those will continue to run as long as the extension or the app is running. So the first use case for that is bootstrapping a window, which we'll show in a second. In addition, you can specify extended permissions. So in this case, Chrome's API specifies that we need to say exactly what we're going to be doing on a network level. So the drone manufacturer specifies these ports on these protocols. There's a few more that we just left out. So we just ask for them up front. The user says OK when they install, and we're good to go. So just to go back one slide, Skynet.js defining the background scripts is what I'm going to look at next here. So as I mentioned, when you specify a background script in an extension or in a Chrome packaged app, it gets loaded and executed on initial app boot. And in this case, we're leveraging this feature called window create and passing in just an HTML page and the width and height of that page. And it will actually render a window for us that looks exactly like a native application. Doesn't have an address bar. Doesn't appear to be in the browser even.
Is it outside the browser?
No.
I mean, the window it draws?
Yes, so it's not a tab. We'll show you in a second exactly what this specific file ends up drawing. And so that's kind of the fundamental component of making this work. And so we've got a bit of a skeleton here. What's next?
All right, so we have a skeleton app. Let's make some real skeletons. So what do we have next? So we have all the components in place, and we know what to do. And our first first run through of the actual code was very much of a hack job. It was very much get it out and get it working, get it flying, and that was it. But I didn't really like that. Like we spent a lot of time doing maintainable JavaScript, well-written JavaScript, testable JavaScript, and I didn't like the fact that it was such a hack job. It was just nested, function calls, and it wasn't very pleasant to work with. So what I wanted to do was actually, as I mentioned, test this. I want to make usage of the amount of real-time data it's sending back. It's sending us a video feed. We have like all the nav data, so on and so forth. And Josh will go into this in a bit more detail later. We have a lot of real-time data getting sent back to us, and I wanted to be able to display that in real time as it's getting sent back. I wanted to be able to migrate this to different platforms. So we showed you how to do the Chrome sockets. But like the actual Windows 8 platform has a completely different socket implementation. I'm sure there are several other platforms out there that support HTML5 that probably have sockets as well, but different implementations than Chrome does. So we wanted to be able to migrate to those different platforms, by separating out the logic. And what did we choose for that? Basically went with AngularJS. So if you're not familiar with Angular, I've come to really take a liking to it. I've played around with quite a few frameworks, including Backbone and Ember. And my personal favorite is Angular, although Ember 1.0 is looking pretty cool as well. Just going through the reasons why we chose it. And AngularJS really supports dependency injection. It was built by Google. Google, they do a lot of Java at Google, and dependency injection is found a lot in the Java world, so they brought it over to JavaScript. And I found it to be really, really awesome. You can do some really awesome stuff with Angular and dependency injection, especially with asynchronous loading and all of that fun stuff. You don't have to do that with a drone, but you can do that in your web apps. So because of dependency injection, that actual code separation is very clean. You have all your dependencies clearly laid out, and like all of your components are they just depend on the dependencies that they need. Because everything is separated as well, you can test it very easily. You just test each and every component individually and mock out the responses. You can mock out HTTP and all of that fun stuff, and TCP in this case. And speaking of testing, like the tools that we actually use to test this are Testacular, which has now been renamed to Karma because Testacular was a horrible name. The Mocha test framework, the Chai assertion library, and Sign-on.js for async mocking. So we're actually mocking out UDP calls and like the actual actually getting the network list and so on and so forth in Chrome, which I can show you a bit more later. And as I mentioned, the nature of the application is a lot of real-time data. We have a lot of data getting sent back to us, and Angular's data bindings makes it a breeze to hook that up to the UI layer. And that's really it in terms of Angular. So Josh, would you like to show us how
Sure.
it's done?
So, and that'll all make sense. If it's over your head, it'll make sense soon. Because we're actually going to walk through some code. Before that, though, I just want to kind of elaborate a little more about the whole sockets thing. So, the fundamental challenge here in writing JavaScript to talk to this thing is native network access. So, in the browser, sending data over UDP and TCP. So it's not enough just to say, okay, well, Chrome gives us this magical permissions. How do we actually do that? And so Chrome gives us this socket API and 3 JavaScript functions that we really need to pull this off. And the first one is just socket create. So JavaScript constructor. And you pass in the kind of socket you want to create, so a TCP or UDP. And then you can pass in some options, and there's a callback. So you start off with that. Once you've done that, you can read from it. To do that, though, you need to actually know how much to read. So you need to know the buffer size that you're trying to read from the port you're listening to. And it returns to the callback the data in a raw buffer array. So if you're like me, you're wondering, okay, I've never done anything like that with JavaScript. How am I going to do anything with a buffer array? I mean, maybe you've got some hardware background and you've done some lower level programming, but what do you do with that at the JavaScript level? And it turns out, actually, that JavaScript has a native data type called DataView. And DataView is pretty cool because you just pass in this typed array of data, and it exposes getters and setters to you to read the data inside of the array in really convenient ways. So these are some of the getters. So just to go back, we read from the socket, that passes back this array buffer. We create a new data view with that array buffer, and now we have these things. And again, we have to kind of know what's in this array. We have to know the byte offset of each part of the data that we're trying to read. And that's all defined for us by the SDK, by the manufacturer. But once we know what we're looking for, we can say, we can specify a byte offset and then get back, maybe it's an integer or a float for various pieces of data. And then all we need to do is just keep asking the drone for this data over and over and over again. So in our case, I think it's every 60 milliseconds, we do socket.read, parse the data, has anything changed, maybe we need to update some of the UI. And fundamentally, that's all that's going on the read side. The other half of that is sending data to the drone. And it just looks like this. It's basically read in reverse, right? So you have to know where you're sending it to, the port, and then you actually have to send it an array buffer. And whenever we want to send commands to the drone, we just use this, and we construct that array buffer, basically in reverse order to reading it. And again, the SDK defines exactly what we need to send the drone to make it, go up or land or whatever. So on that note, this is new from last Thursday, the first time we gave this talk. We've implemented a little bit of the Gamepad API. And if you're not familiar with this, if you're running Chrome or Firefox, you can actually just plug in a controller, like a USB controller, like an Xbox controller, I mean, and use it in the browser. So that's really cool, except it's not, because Chrome's implementation of it is terrible. So you read it just by asking Chrome to tell you the device status, and it'll send you back an object with the status of every single button. But then you have to ask it again, and again, and again, and again. You have to pull for it. There's no callback. It doesn't tell you when it's updated, so you have to just keep asking, hey, controller, is there any data? Is there any data? Is there any data? And that really sucks, because it's native in the browser, so you would expect that they would do something a little smarter, which is what Mozilla does. So Firefox, there's the Gamepad will tell you if there's new information. So we're gonna demo that a little bit too in a minute. But along the way through all of this, and this is still a little high level, we had a number of pitfalls that Taz can address.
Perfect, thanks, Josh. So I guess going on with the Gamepad, a pitfall we had with the Gamepad was sometimes it worked and sometimes it didn't.
Right.
So we noticed that
that's typical in web development.
Yeah, yes, it is. Yeah, it's not very
I'd say that's the
Chrome,
number
though.
one bug.
Statistical programming at its finest, right? Sometimes it works, sometimes it doesn't. But anyway, so sometimes this worked and sometimes it didn't, and we found that we had to restart Chrome to get it working again. So it wasn't very.
You have to plug it in before you start your browser, and
yeah, it just wasn't very
You have to actually press a button on it before you can read it to prevent device fingerprinting, which is actually a good thing. So advertisers can't figure out who you are because you've got this device plugged in. That was just a gotcha.
Yeah, it was just a bit of a pitfall with that. So next up, the actual video feed. So we mentioned, the drone has a camera on it, and that's all fine and dandy, but it's giving us back H.264 baseline. And if you know, Google doesn't like H.264 at all. They like VP8. So we can either do a few things here. We can pipe it through FFmpeg and get back a like a H.264 baseline, or sorry, get back VP8. We can do something like that, or we can just keep polling it and dumping it out to a PNG, reading in that PNG with file reader API into a canvas or something a bit crazy like that. But anyway, the actual video was tough, and that's unfortunate because Chrome has some great APIs for this. So there's the media source API in Chrome, and that allows you to basically create a frame buffer, which is like a frame of frame of a video, dump in like raw data into that, and then
Chunked
it will
too.
Yeah.
You can send it in chunks. And
Exactly. So send it chunk data, and it will assemble frame by frame and play you back, the actual media source. So it was really annoying that we couldn't actually leverage this media source API, which just looked so damn cool. It was actually a few of the times we had to read Chrome source for this project. So I think we read Chrome source for that. We read
we wrote the WebKit source. Yeah.
We were reading the WebKit source for the media source API. We ended up reading the drone source to figure out a few things as well. So we're reading through a lot of C. but funny enough, we found out that the WebKit source was actually pretty good. Like it actually told us a bit more than the spec did as to how it's actually all working. Which is a bit
if you're
weird
interested in media source and all like streaming video through JavaScript, there's not that much out there. You have to actually kind of read the
source.
WebKit source. So you're going off into crazy land, basically, at this point. That's why it's a pitfall.
Yeah. So the actual hardware design. So as Josh mentioned initially, the actual cross brace here broke. It's snapped in two, sort of this way. So we're sort of doing that, if you can imagine what that would be like. And something we found was, if you take a look at this, so these are sort of stuck on here, like these are on the side here, sort of stuck on. This bottom piece here is stuck on as well. There's actually a camera here on the bottom camera, which is kind of cool. So there's a front camera and a bottom camera. But this bit here is stuck on. Basically, in order to get this cross beam out, we had to take this bit off. There's actual logic board underneath this. We had to detach that, and if you've ever done any stuff with hardware, it's always a bit unnerving when you start detaching stuff from a logic board. So Josh fortunately had the iFixit Mac toolkit. I'm not sure what the technical term for that is, but basically it's the thing that you need to fix Macs, right? Like it comes with all the custom screws that Apple likes to use for their products and all that stuff. But anyway, there were screws like that on this device that we needed like that actual kit for, and that's a bit crazy. Once that was done, actually removing it was difficult, and then actually putting the new one back in was difficult, and then reattaching it was just a nightmare. So the hardware design was a bit of a pitfall as well. My advice to you is do not break it.
It's easier said than done.
It's easier said than done. But there happens to be an emergency mode. Do not turn on that emergency mode. Okay, so that's how it was destroyed in the first place. Lastly, time. Time is always a factor, but time. It's been a bit crazy for both of us over the past few weeks, and unfortunately, we just weren't able to do as much as we wanted to do with this. We did a bit more this week than we did last week, but we're still not quite enough that we wanted to do. But fortunately, as Matthew mentioned earlier, I'll be speaking again at the Windows 8 event, or the web app event on April 6th, and I'll be going into more detail there on how to do cross-platform Angular. So I mentioned Chrome has its own socket implementation. Windows 8 has its own socket implementation. They actually do like raw datagrams, which are pretty cool actually. They basically made their C# API accessible through JavaScript, and JavaScript promises instead of callback hell, you have promises, which are much nicer. And and Microsoft has put this in the Run.js platform, so that's pretty cool to me. So I would like to port the same app over to the Win.js platform, and go through any challenges that we follow through on the way. So anyway, enough talking. Let's take a look at some code. So over here I have Vim opened up, and you can all see that, I take it, right? Can anyone not see it? No? Okay, cool. So first things first, here is our manifest JSON that we went through earlier. So, manifest version 2, the name, the background script, the permissions, all of that fun stuff. So something that struck me as kind of interesting with this project was the amount of security built into Chrome packaged apps.
Right, yeah.
So like as Josh mentioned, we have to specify the exact ports we're using, the exact connections we're making. But there were a few other security related things which I found kind of cool with this app. So one of them was this is our index.html. This line here, our HTML tag. So ng app Skynet. So that basically says our Angular app is the Skynet app. We can have multiple apps embedded in the page in Angular. Here I'm just using one for the entire app. This ng CSP directive. So that stands for Content
Security Protocol.
Content Security Protocol. And we think. Don't quote us on that.
It basically prevents you from running things like eval or even iframes. And it really hardens the DOM to prevent, XSS basically.
Exactly. So it ends up being a performance hit, but it's not really noticeable at all. Basically, you have to include this directive using Angular 1.0, but 1.1 you don't need it anymore. They've actually they're not using any of the code which violates the security issue. But other than that, it's pretty generic Angular app. We have. Oh God. We have an ng repeat directive down here. Some stuff on our controller. We have like a template there. Our battery. State, altitude, so on and so forth. So it's a pretty standard Angular app as far as that goes. So let's get into how we actually did this. So here's our Skynet.js app. Simple Angular module. Our controller. So this controller, as we mentioned, we started with a hack job. This controller, unfortunately, still is a bit of a hack job. You can see we're requiring far too many dependencies in this one controller, but that's okay. At least it works. So I mentioned before, I've come to take a liking to Angular. One thing I really like about Angular is private functionality. So in my JavaScript, I really like like using closures and having functions defined within that closure, and only making accessible the public functions that I want other people to use. So I have essentially private functionality that nobody else can access, and public functionality which I'm exposing through like my actual return statement, the actual object I'm building out. If you use Node.js, the modules system is essentially what I'm talking about. Angular, it's everything's within this closure here. So we can define functions like this one, and this is a private function only available within this controller. So that's one thing I really like about Angular. I'm sure you can probably do that in other frameworks, but I just really like that. Anyway, so here we're getting a network list. So this is Chrome. Chrome's get network list function, and that basically says, this gives me a list of all the devices on my network. So I can determine my client IP, so my machine's IP. Initializing, connecting all the sockets, as Josh mentioned. So if it's a UDP type, or this is a bind or connect type. If it's to the drone or from the drone, so on and so forth. Once they're all connected, we want to be sending a keep alive command. Tell it to start on a flat surface. So we don't want it to start on like an angle or something. We want it to start on a flat surface. Send the sensitivity. Tell it we're flying indoors. Get the nav data. So, like the actual GPS coordinates, altitude, the battery, so on and so forth. Start sending and tell it to start sending commands, and then our loop. So that's every 60 milliseconds, just send more commands over. These are all the implementations. So just socket sending to the nav socket, for example, a uint8 array. So if you've done any WebGL, you've probably used a lot of uint8 arrays and float 32 arrays and all that fun stuff. So yeah, so that's another place that you could use it as well as WebGL.
Yeah.
More socket reads. So this is our send command function, which we use almost everywhere to send commands. So sends those commands over, sends the outdoor command, gets all nav data, take off for land. This is our loop. So this is basically the core of the app that's getting sent every 60 milliseconds, as you can see down here. This could be improved using Angular's bindings. As I said, it's still a bit of a hack job. But anyway, I'm happy to accept pull requests. This basically tells it to take off or land. This tells us, the actual tilt of actually controlling the drone itself. So these here controls the up, down, left, right, and the control classes, that's used for the actual UI layer. So those are the buttons you'll see on the UI layer and stuff like that. Cool. So I told you I'd show you a spec. And you know what? Let's take a look and make test. So this will launch Testacular using Phantom.js, and as we can see, we have some failures in our test suite. So it expects some things to be defined, and it's not defined. So I'm going to do some death by live coding and get this test suite back to green. So anyway, let's do that. So what do we have here? Where is this? This is in the control spec. So let's take a look at our control spec. So spec, control spec, and this is how I test in Angular. So I'm describing my control service. It has, I need to make the actual control service available to my test itself. So what I'm doing is I'm injecting the control service and my window object, assigning it to the variables in the proper scope. And then I can go ahead and actually do some testing. So it exists. First and foremost, it should exist, right? So here I'm using Chai's should API in order to do all my assertions. A window extension. So onKeyUp is a function. I'm accepting key events here, so I want my onKeyUp to be a function, my onKeyDown to be a function. So, you know, let's see here. Oh, that's really small. JS services controls. So when I'm doing stuff like this, onKeyDown equals function, you know, I just want to make sure that they are indeed a function. Describe the states. So I believe this is probably what was failing. Is states is not an object? No, sorry. This down here was failing. So it doesn't have all these keys. It doesn't have those own properties, and that was a failure. It has all 0 values. I believe that was also a failure. No, that was a pass. You know, onKeyDown. So when I run the onKeyDown, I'm going to close this. It's taking up too much space. So when I execute the onKeyDown on window, that appropriate key name should now be equal to 1, for example, right? Same thing with onKeyUp, and that's basically my test. So let's make this pass quickly. So let's see what was failing. Object vertical speed, angular speed, does not have the property space. So that's because we were hacking in this last night and we did not update the spec suite. So let's just do that now. So controls. So now our states has a vertical speed, angular speed, front, back, tilt, left, right, tilt. And all we have to do is probably change this. So vertical speed, angular speed, front, back, tilt.
Context naming.
Cool. So let's see if our test if that test passes. I find that the new Testacular or Karma takes longer than the old one did. I'm not sure why, but anyway, that test passed. So next up, when we hit that button, it goes to 1. So it's no longer a button now. It's more of a it's the actual vertical speed. So when we hit what key code are we using here? We're using space. All right. So when we hit space, that's actually not the best option because we don't have a space movement here. So our controls are space takes off and lands. WASD is it's basically Counter-Strike controls if you played any Counter-Strike. The WASD is front, back, left strafe, right strafe. The arrows are vertical up, vertical down, and then rotate. So we don't have space because it's not any of our movements. So let's change that quickly. Say 87. Sorry, and if there's any questions, please just yell it at me while I'm doing this. Or Josh. Anyone? No? Okay. So when I hit the W key, the front, back, tilt should be 1. And when I hit, let's change this as well, this is 87, W, when I hit that key, so I want this to be front, back, tilt. And this should be, that should be that. And hopefully everything now passes.
Don't cross your fingers.
Oh. Okay, only one failure. Front, back, tilt.
Maybe it doesn't like the accessor that way.
On key down, key code, key name. No, it does nothing to do with the accessor. What was the actual error? On key down sends the key name to 1.0. Okay. If anyone knows the problem, let me know. Feel free to tell me.
Death by live coding.
Death by live coding.
One failure is okay.
One failure, yeah.
Deploy.
That human will get away. Cool. Well, okay, we'll leave it at that for now. But anyway, if you want to send me a pull request and fix that, you're more than welcome to. This will all be available actually in a few minutes. Sorry, I just have one more thing I want to show you, which is our async mocking test, because you may find this interesting for your own work. Client spec. So this is the Chrome client. Get network list here. So it calls chrome.socket get network list. It asserts that it should have been called. So to give you an idea of what the code looks like. Client, so this is the code here. So my client.getNetworkList, this is Angular factory. So whatever I am returning from this factory, so I'm here returning client, is now the value of this factory, of this dependency. So here it's just an empty object. I'm defining this getNetworkList on this object. And what that's going to do is going to call Chrome's getNetworkList, and that's going to return some results. Cool. So that's some async mocking, some async, I need to test some async functionality. And the way that I do that is I call client get network list, and as we can see, that is going to in turn call this get network list. So that should have been called. Chrome socket get network list should have been called. Nice and simple. If I call a callback, its internal callback should have been called. Nice and easy. Now down here, the callback that I pass into here should have been called. So client get network list with a sign-on spy. So that's essentially a stub. You can assert that it has been called or has not been called. When this here callback is called, the callback I passed in should have been called. Okay, so some async mocking there. And this is just to test the actual results. So at the end, taking a step back, something I really like about Mocha, the Mocha test framework compared to like Jasmine or QUnit or a few of the other ones, is Mocha really embraces async testing. If you've ever done any async testing in any of those other languages, you know what, I'm going to pull it up right now. If you've done any async testing in Jasmine, for example, you got to know the runs function, right? So you got to know all about this, and then you got to know how to use it down here, and you got to know about waits as well. So that's important. Waits is important. And then you got to keep reading docs, and waits for something else you got to know about. That's about it. So you got to know that entire page of async testing, and that's a bit of a pain. Mocha, all you have to do is, that's a bit too big, is to do an async test in Mocha. What you got to do, so this is a synchronous test. Nice and simple, what you've seen before, nothing fancy there. In Mocha, all you have to do is you pass it a done callback. So you say, it should say without an error, function done. You pass in an argument here. That argument is a callback, and you call it when you're done. That's quite literally it. You don't have to know a full-page documentation. You just pass it a function. That's literally it. This follows Node.js conventions. So if you pass in an argument to the done function, it considers it an error. So in this case, we're having a user.save that accepts an error. So we can actually just do the done inline here. So user.save done. And if there is an error on user save, it will consider that a failure. So it's just nice and simple. You don't have to worry about a full-page documentation to do async testing. So anyway, that's what I'm doing here. I'm asserting that the results are equal to that, calling my done function. So when down here, I actually yield to this callback these arguments. This functionality in here, so this functionality here should then be filtering out the right results and returning me that. So anyway, that's just an example of how I do async testing and how you can do async testing using sign-on. I'm using Mocha, Chai, and Testacular Karma here. So anyway, this will all be posted online, in fact, right now. Go to Tasveer, Skynet, and settings, and make public. Type in Skynet. All right, yes, I understand. Cool. So there you go. github.com/tasking/Skynet. There it is for you. So all the code's online. All those specs are online. Feel free to fork it, send me a pull request, build your own drone, whatever. So now we got all the code out of the way. Let's fly the thing. So It's our phenomenal app.
So this is the Star Trek Alcar's UI.
Now, Matthew, I'm not sure if I connect to Wi-Fi. I'm just going to disconnect over there. So,
and if you do, then we'll figure it out. But you should.
all right. So just disclaimers.
You
So
knock on wood.
That's not wood. Not really. Okay.
oh, sorry. So as I mentioned, we have to connect to it via Wi-Fi. So Wi-Fi takes a little bit. Okay, it seems to be connected now. Are you still connected over there? What, Matthew?
Yeah, we're good.
Perfect. So let's reload our app since we're now connected to the Wi-Fi, so it makes all the proper connections.
So
as we
before
can
connect,
see,
I just want to make sure. Raise your hand if you do not approve of a helicopter going in this room and you potentially may have an eye poked out. Let the record stand that nobody raised their hand, so everybody can stay in.
Oh,
Awesome.
we're
covered.
I think it died.
you think
The
what died?
screen is no longer the same.
Oh, the screen is no longer in sync, Matthew.
Screen is no longer in sync.
Yeah, we have a different screen up
Okay.
here than we do over there.
We'll just turn it around.
Yeah, you know what? We can just turn it around. We can't really see what we're doing, but sure.
How is that not sync?
It's not.
All right, so you can just look off of that, and we may be looking off the same screen. So, anyway, so I guess to demonstrate the Gamepad API, what we've done. So I'm not sure if you would want to hold it, Josh, like that.
Sure. So make sure this is on first, and then restart Chrome.
Restart Chrome. All right, but I've already started Chrome.
Just restart it.
Oh,
From scratch.
Chrome.
From behind.
So there's a simulate browser restart functionality here. I'm going to try that.
Well, stand in front.
All right. Oh,
Yeah, just go
geez.
around. Come on, right here.
So you know what? I'm going to detach my monitor then.
So does your joystick gadget run over Wi-Fi?
The
So
joystick itself.
It's connected to the laptop.
How?
It's got a USB dongle.
Oh, it's hardwired.
Um,
No, I
and-
thought your little gadget with buttons on it.
This one here, sorry.
Yeah.
Yeah, it's connected via this. So yeah, you can actually get the PS3 controller connected via Bluetooth to your computer, which is kind of cool. Yeah. So anyway, okay, let's close Chrome. Oh, reopen Chrome. Chrome extensions. No, I missed the R.
Maybe I could get a sponsorship from ARDrone or Parrot.
Let's launch that. Okay, so here is our app. Let me try to make this a bit bigger so everyone can see a bit. There's our app. Cool. So anyway, Josh, you have the drone.
Okay.
Do you want to get on the stream maybe so those
Sure,
guys
yeah.
can see? And hopefully this controller will work for us now. So I'm going to press the A button. Oh god, there it is. So it's trying to take off.
Don't press it too many times.
It's trying to take off. So anyway, that's how you can get the actual gamepad controller working. As we mentioned, it's not fully functional yet because of the polling we have to do. It's just a bit of a silly API. So there's too much stuff we had to do to make it nice and work well. So we didn't really do that. But we did get the Counter-Strike controls working. So you can make a headshot. All right. So, death by flying copter up next. Cool. You want to make sure it's not going to kill anything, Josh?
It's not.
Okay.
It's gonna kill something.
I asked.
Just a sec.
Okay.
The parts are replaceable, remember?
And we have two of them.
And we have two of them.
So is this the Radio Shack drone?
The source, yes, it is.
You good, Josh?
Radio Shack.
Yeah.
Sorry.
Okay, cool. Let's try this again. I'm going to reload my app so it remakes the connection. No, not connected. I must not be connected to Wi-Fi.
Yeah. It disconnects the Wi-Fi.
Yeah, okay, I'm reconnected to the Wi-Fi. I'm still not connected to the drone. Let me turn off my Wi-Fi and turn it back on. So back to the pitfall section of our killer drones. I swear. We'll have all the bugs ironed out for V1. Okay, so it's connected. We can see the battery is working on here. I'm not sure how well all of you can see that, but if the battery is functioning here and the state is functioning, we know that it's connected. So let's try this again. Thanks so much, guys. I hope you enjoyed it. Any questions? Yes?
Yeah, looking at your battery, that chewed over 30%.
Yeah. So back to the downsides.
So I guess it's related to payload. So if you take that bicycle helmet thing off it, the foam or whatever it is.
Yes and no. I mean,
no?
this is very lightweight. It's maybe a few ounces. Overall, the batteries are not strong.
So for $300
you get
70
9 minutes of flight time, which is more like 5. Takeoff takes a lot of energy because you have to generate a lot of lift, right?
How long do you have to recharge it for after those 9 minutes?
Oh, that's the best part. It only takes an hour and a half. So we have 5 batteries here tonight, so we can go
have fun
go take it out in the big area, I think.
Yeah, there's a large flying area outside that we can take it out in. So anyway, we're encouraging you to get this on your laptops. It's just available on GitHub. Just clone the project. You can easily add it to Chrome extension. Just do Chrome / extensions in your browser. You can load the packaged app from the folder, and that's literally all you need to do to get this exact same app up and running on your machine. So feel free to do that. We have 2 drones here, so we can do that all outside. But anyway, before we do that, any more questions? Yes.
Video?
Video. Sorry, what about the? Oh, so in order to get the video.
Yeah,
working.
just.
Yeah, sure. So I can show you that. So we ended up getting it working through ffplay, which is a binary that comes with ffmpeg, and let me see if I can get it up and running here for you. One moment.
So if you're developing on a Mac and you've got brew installed, then you can just do brew install ffmpeg.
I'm also a.
Get it.
Oh, geez. Yeah. So it's not up there for the live stream, guys. But anyway, you should be able to see that here. This is going through ffplay, as I mentioned. So this is doing the, it's doing all the real-time decoding through ffmpeg. So it does work. It's just Google doesn't like H.264 baseline.
Taz mentioned one of the schemes that we came up with, maybe to get around this a little bit, the fact that we couldn't just dump it into the browser. So there's a function, there's an argument you can pass to this this binary that will print the frame to an image file locally, and then with JavaScript you can just refresh the source of an image tag, and you will get the appearance of video because as long as it's local, the I/O will just be fast enough to render roughly 30 frames a second. So we got that, but that didn't really feel the best because
native client.
Native client, yes. I'm sure you can do it through native
Yeah.
client if you did like an H.264 codec or something like that.
Absolutely.
Sure, but it gets back to the time factor, right? So you just don't have time to start messing around with native client and all of that. All of that would be pretty damn cool. I'm not sure if you noticed, if you can see my screen, I'm a huge fan of make files, nice and simple. So to run the test suite, just make test. Run the video, is just make video. Make a PNG, is make PNG. You can take a look at the makefile itself and look at all the commands that we're using to actually do that with the drone. I'm sorry, I think you had a question over there.
here.
Oh, I was wondering if Chrome extensions work on iOS as well.
Chrome
No.
extensions.
No, Chrome Mobile does not support extensions at this point. Firefox does, interestingly. Maybe they will. I mean, it makes sense to me that they would, but who knows?
Cool. Any other questions? Yes, in the back.
So you're saying that the Gamepad would work properly on Firefox, right? No.
Yeah, so it works properly in both. So maybe I can just explain a little bit more. Basically, when you plug in a controller into your computer and open both browsers, you can use a function called get gamepads, and that will return you a list of the active gamepads and their state. With Firefox, you can pass it a callback, and it'll keep calling that callback every time it changes state. But with Chrome, you have to actually write some polling. So in our case, we used a request animation frame, which lets you execute JavaScript only on every page paint. So actually painting the browser screen, which happens 60 frames a second in Chrome and Firefox.
And there's a bunch of advantages of using request animation frame opposed to like a set timeout. First of all, it's browser accelerated, so like set timeout, like it is and it isn't. It's just faster with request animation frame. And
you're not.
Secondly,
if you use set timeout and the low time, then you'll drain the battery on the controller. So if you're developing like some HTML game and you want to use the Gamepad API, you absolutely have to do it this way, because otherwise your user will use their entire battery in half an hour, and they probably won't be happy with your game.
So that's only like 4.5 hours of charging the drone.
Yeah, well, maybe they can play the game while they're waiting for the drone to charge. There you go.
Sorry, I think you had a question as well?
Yeah, is there much lag in the control?
So the question was, is there much lag in the control? We found there was actually like next to no lag at all. It's pretty good. Like, and that's where the UDP comes in. It's sending it all over UDP. So
it's happening every 60 milliseconds.
Mm-hmm. But I mean, even with Angular and everything,
no.
Black magic.
Black box.
No, we didn't find any lag with the controls at all. Yes.
I've had nasty experiences with high data rate UDP. The higher you go, the less gets through. What are you finding? I guess it's fairly low data rate.
Well, yeah, and if you look at the actual
and just repeat the question. So the question was that he was having a bit of trouble with UDP on a high data rate. Now, how does this device cope with high data rates? And as Josh was mentioning, and as you mentioned, it's a relatively low data rate. The highest data rate you're going to get, I guess, is the video feed.
Yeah,
And
then the video
low.
does actually is prone to dying, ostensibly for that very reason. That we don't
It
really.
doesn't block. So I mean, that's the advantage of UDP.
Yeah, I mean, you just, as long as, natively FFmpeg is really bad. You have to pass a bunch of args to get around errors. So the first time a packet fails, it just shuts off. But I'm sure you can get around that.
Cool. Any other questions? All right. Thanks so much. I'll give it back to Matthew.
So, outstanding. Now, I know a bunch of us are probably anxious and eager to see if we can get our hands on either this one here or possibly even the other one. I see that's still on, so we might have to swap that out for a battery. We do have another 4 batteries on top of that, and we do have permission from Mars Commons and Mars Discovery District to do drones, to fly the drone on the one side of the security thing. But again, I gotta say, if you get hit in the head with it, it's your own damn fault. So with that being said, one last thing before we do go. You guys know I do like competitions. I do like giving out free stuff, especially for the people that come out to this. So I'm going to say, do you guys have a question that you want to ask the audience here? And so the prize would be either, where is it? Oh, I know. The prize is either a T-shirt from Microsoft, the developer movement program that they have. So I've got the T-shirt there, as well as I have the absolute last copy of HTML and CSS that the group owns. So this one here is, admittedly, I wish that they were a sponsor, and I wish they gave it to us for free, but they didn't. But this book by John Duckett is an amazing, amazing book. I don't generally like having developer books because as soon as they go to print, they're out of date. This book, completely different. It's pretty much like a Wikipedia, or Wikipedia. It's like a dictionary of really good CSS practices, HTML practices, semantic tagging. Really, really good. If you guys talk to the author, he's really, really responsive in both email and Twitter. I've had a couple conversations with, or at least one conversation with him, going back and forth. Hey, you left this out. What about doing this? And just going back and forth. Really, really good. I do recommend the book if you don't get it today. But I wanted to give you guys the opportunity to ask a question to everybody here and see if somebody can get the answer right. So something technical, maybe not a UDP question.
They just wouldn't get that one.
Second time.
I didn't tell it twice.
It took me a second to get that the first time. I was.
That's funny too.
I wasn't really sure if you got it or not, though. Sorry, is this overkill? I'm not sure if I'm overkill. I don't know. What's a good technical question, Josh?
Should we do a competition to tweet something? Should we?
Let's think about this one. Let's see how long our neckbeards are.
Can there be some judging aspect to?
Should we do some judging aspect to this?
So, like, if the question goes down, we'll see who answers the best. It might
Sure.
not be a straight. Okay, who can name the most obscure HTML element?
Who can name the most obscure HTML
There are a lot that
Interesting.
you
That's
never use.
Raise your hand if you're here, if you're local.
Like a tag? Valid HTML?
Like a tag, just a tag, an element. Yeah,
Yes.
You.
it's okay.
D P. Yes.
Marquis is okay.
No script. Ooh.
No script.
Abbreviation.
Abbreviation or
Little
breadth.
better.
Yeah. Yes. Definition. Although very underused, that should be used. Anybody else have any suggestions? So, who's the winner? Who's the winner?
I'm gonna know over here.
Yes?
Progress.
Sorry?
Progress.
These are pretty commonly used.
What's the winner?
We have one more.
One more?
Data formats?
Data format, like data dash format.
No, just data formats.
I don't know what that is.
That's obscure.
That's really obscure.
Is it real?
We may have to look that one up. Data formats.
Is that standard?
I can say stuff like that too. Glasses?
Bacon.
IE6. Doc type. Doc type's pretty obscure, yeah.
Look up data formats.
Those are all kind of bad. Marquis is good.
So, you gotta pick one. Who's the winner?
I think definitionless is pretty good.
Definition list, obscure yet underused. What does everybody think? Yes or no? Yeah? Consensus? Yeah? Definition list it is.
Right.
So
We have a winner.
So, t-shirt or book? Book? Are you sure? I'm going to throw it up. You can come up afterwards and whatnot. So,
What were some ones you were hoping for?
I'm just trying to bring up that stupid site W3 Schools or whatever it is.
Oh.
Because they've got like this list. I was on there the other day asking this very question, like, what is the most ridiculous obscure tag? I mean, even doc type is kind of silly.
Yeah, there was doc type mentioned.
It's not obscure though.
Yeah.
Cool.
Does anyone know why doc type exists?
Anybody? Nobody
It's at
knows
the top
why
of every single.
Yes.
Well, so the browser knows how to parse.
But which browser? Yes. Internet Explorer is.
So, for that one,
Microsoft couldn't figure out. Oh. Yeah, that's why it exists.
so with that being said, there's one last thing I wanted to do. So I'm going to switch it over the stream just for those guys, but I'm going to talk from this angle just because I got to control that. And awesome, we can switch over. So FITC, as you guys are probably aware, you guys know what FITC is, right? So they're hosting an event in Toronto coming up in April. I wanted to give you guys a heads up on. First of all, so we have tickets available for the group. Right now, we have 30 tickets available for 15% off, right? Using the code HTML5TO. I believe that's what the thing is. It isn't on this, but it's HTML5TO for our group for 30 tickets. After the 30 are gone, or if that's taken, you have HTML5, which is 10% off indefinite. So as many as we can get. 10% off. Trust me, these events. Who here has been to an FITC event recently or in the past? Are they good? You learn a lot. Meet great people. Conversations. Really, really good. Seriously, I'm not a speaker this year, so I can't really say, oh, they're great speakers, but I have been in the past. So another thing that they're doing is really pushing forward women in tech. Who here is part of either Girl Geeks Toronto or Ladies Learning Code Toronto? Anybody? Yeah, a few people here, probably even a couple speakers maybe, have been out to these events. Really, really good. FITC is also trying to promote this by having anybody that is a girl or a woman that wants to be involved with tech or wants to either is involved or wants to be more involved. If you make a video, a short film, a blog post, etc., and submit that to fitc.ca/women, they are giving out tickets for that as well. So they're definitely something to take a look at for anybody that wants to get into the field. So we have technically 2 tickets to give away. One is going to be from anybody here tonight or watching on the live stream, because we're going to be giving this out right away, well, at least within the next 24 hours. If you want to win an FITC Toronto ticket, tweet HTML5_Toronto, send me to @FITC Toronto. Just kind of a weird one. If you don't do the HTML5_Toronto, I'm also following the HTML_TO or HTML5TO hashtag. So that's to get one ticket. The other ticket is going to be given away on likely Sunday or Monday of next week, and it's to anybody who's on the newsletter or likes our new Facebook page. Now, I know I'm not a big Facebook person myself. I don't generally like using it for massive events. But there are people who like it for events and keeping track of things, and they use it more than LinkedIn and whatnot. So I have created a page for us on Facebook. I believe it's facebook.com/HTML Toronto. Again, there's links on our website and whatnot. And I will be giving the second ticket away either Sunday night or Monday morning to one person, a collaborative list of anybody who likes us on Facebook or is subscribed to our new newsletter. Again, the link to that is on our website at htmltoronto.ca. So that's it for basically the event. But like I said earlier, we are going to be doing a, hopefully both live streaming us flying all of this stuff out in Mars Commons, if bandwidth allows on Wi-Fi, because we'll have to switch over to Wi-Fi instead of hardline, and hopefully giving you guys a little bit of a chance to control. Are we giving them a chance to control this?
Oh, yeah. Oh,
yeah? So for you guys to control one of the drones in the area here, again, I'm going to say to you, please, if you are a person that's controlling it, we need to stay on the one side of the giant bridges that are going across. And if you do get hit, it's your own damn fault. So awesome. With that being said, if there's more pizza and drinks in the hall, grab some. We do got to do a bit of a tidy up and clean up here while we grab the camera, put the stuff out there, grab the drones and whatnot. But we will see you guys out in the hall. If you're not up for that and you want to go home because it might be still snowing a bit, thank you so much for coming out. It means a lot. And I hope to see you guys at the next event. So thank you.